Our next speaker, Taylor Arnold, is going to be talking about computational approaches to pacing and style in television comedy. He's a professor of data science and statistics, also at the University of Richmond, Virginia. I don't know if you've met each other. His research applies and develops corpus-based techniques and software to study how messages are communicated through visual and multimodal forms. He's particularly interested in understanding the production and reception of messages transmitted through time-based media, such as television and film. And since I don't want to take up any more of your time, I'm going to hand it over to you.
Yeah, thank you so much. Thanks for having both of us here. Yeah, really excited to talk about this. I'm going to jump right in kind of where Lauren left off with some examples of, or an example of an analysis we've been doing with some data for that. So my original thought was that I would present this paper that Lauren and I wrote for CHR 2025. And then I saw the list of participants and they were almost all at CHR. And I didn't think, you seemed excited then, but I didn't think you seemed excited enough to see the same talk again. So instead, I'm going to show the extension of that work, which I think we have some interesting things to show and some results, but it is still a work in progress. And that's actually kind of nice because I think we'll start some dialogue about where we're going. And this is very much a study that is part of a bigger project, a book length treatment that Lauren and I are working on that she alluded to as well. And it's partially funded with the Schmidt Sciences grant that we're doing with David Bamman, who's here, and then Allison Cooper at Bowdoin. All right. And so the main research question that I'm going to try to address today is to what extent and in what way do structural elements of television comedies, and we're going to look at multiple different kinds, to what degree do those structural elements help us distinguish subgenres and as well as individual series? And there are a few subparts to this. So first of all, what are the best ways to measure the relationship between a set of structural elements? So how can we actually measure this? Usually I present with Lauren, but I get to present today. So I'm going to show you some statistics, which is really fun for me. And then also from there, we're going to go into, as Lauren was talking about, the cinemetrics, this idea of pacing and what does pacing give us? And then contrast that with other visual features, which we can now get with state-of-the-art methods. So our original analysis worked with what we've now split out into about 4 categories. So the first are the network era sitcoms. These are really the foundational form of television comedy. I say network era, which is about starting in the 1950s. They even go back, they have a longer history than that. But probably one of the formative ones is I Love Lucy that really pioneered the idea of a multi-camera setup. You can see here, this is a model of the I Love Lucy set from the I Love Lucy Museum. It does exist, so you can go see it. And you can see here that there are like 4 different cameras that are all on at the same time. And this gives it a very theatrical quality and there's also a live studio audience. So like Lauren was saying with the laugh track, so they capture the people laughing and then they mix that into the audio. And the idea is that you play out an entire scene from different angles, and then in the cutting room, you block it out into to what we see on TV, where you see different angles and you go back and forth between a long shot or a close up or we're going the dialogue of the series. And then this is really contrasted, and our original study focused mostly on how does that differ from the single camera sitcoms that we watch nowadays. Things like Arrested Development, kind of one of the earlier ones, or 30 Rock, or Modern Family, where they have much more of a cinematic quality to them. They're actually shot with a single camera. And this took me a little while to get over that single camera is more complex than multiple cameras. And the idea is that means every single time you're shooting, you shoot like one shot, and then you move the camera and you shoot another shot, or you have to shoot a scene multiple times from multiple different angles. And this means that you use real sets. So like the house on Arrested Development is an actual house. I don't know if it's actually falling apart like on the show, but it is an actual house. The one in Modern Family is actually a fancy house somewhere in LA. And then we originally thought of this as a similar category, but have now split it out as we've been looking at more granular approaches of these mockumentary style sitcoms. So we originally thought of this as just another form of a single camera sitcom. But now we've actually been thinking about this actually as having its own structure to it. So the pioneering example of these mockumentary style sitcoms is the UK's Office, which was just a mini series, very short. But then that became popularized in the US adaptation of The Office. and then has gone on with other notable examples such as Parks and Rec, and What We Do in the Shadows. And so we've actually noticed that because of the talking head and some of the shots that they use that are documentary style, that it does actually have a different stylistic quality. But I'm getting ahead of myself. We'll get there. And then the other one that we've actually mixed in here are genre parodies. So traditionally TV, you had hour-long serious dramas, and then you had half-hour-long sitcoms and funny things. But nowadays, you actually have genres that mix together. So like The Good Place, which is kind of comedic, but also kind of serious, and it's also 30 minutes. A real, I will admit, guilty pleasure is Psych, which is it's like on paper, it has all the structure of a gritty police procedural, but it is nothing but like goofy. And then Only Murders in the Building, parodying not just a genre, murder mysteries, but also a meta-reflection on podcasting. So we think of these as kind of a separate category. And then one that I try to avoid, but I can't help myself, politics and news satire. This is actually a British invention that started with That Was the Week That Was, TW3, in 1962. It did such a good job of lampooning politicians who were in charge of the BBC that it got shut down after only a year, and then picked up again in the about a decade later by SNL's Weekend Update with Chevy Chase, and that continues to today. It's actually all over. It's serialized in Twitter and Facebook and YouTube and everywhere. And then we have, this has actually become a whole subgenre with things like The Daily Show, The Colbert Report, and Last Week Tonight. And there actually are non-English language versions of this. Germany's Heute Show, it's actually incredibly popular. I only learned about it when we were starting with this. But it's like 2,000 episodes on YouTube, and it's incredibly popular. And a very, the host of that has been described as the German Jon Stewart. So he does kind of look like him. So you can see that there. And then kind of going away from those traditional forms, the other form that goes all the way back to vaudeville is sketch comedy, and we do see this, for example, I just said Weekend Updates, part of SNL, a lot of SNL is sketch comedy. Probably one of the biggest pioneers on TV would have been Monty Python's Flying Circus. There were much earlier versions on the US television as well, but most of those are lost. They weren't really recorded. So Monty Python's Flying Circus is one of the first ones that we really have here. And then they go on and on. Other examples in the US and European context. So now those are what I think of as like the American shows. So let's go over to Britain, and I'm going to tell you about a kind of formation that's particular to Britain, and then we'll go to one that's particular to France. So these are the British panel shows. Has anybody seen Taskmaster? Yeah, okay, it's great, right? I tried to find a little snippet to show you, and I got so distracted watching it because I love Taskmaster that I couldn't actually find a good snippet that wasn't 20 minutes long. But I highly recommend you watch it. It's all free on YouTube, which is really awesome. And so this is a subgenre it's a uniquely British invention, and it's basically different game shows. Taskmaster being the most well-known outside of Britain, but there are others like 20 Questions, Just a Minute, Have I Got News for You? I always forget it. 8 out of 10 Cats does Countdown. And it's basically comedians playing a game show where they don't care at all because they're comedians and they all know each other. And that's what's like pretty uniquely British about it, is there's this whole panel of stand-up comedians that know each other, and they play off the fact that they know one another. There was an American version of Taskmaster. It was horrible. It got canceled after one season. But there are some others. I know we have some Scandinavian experts here. So it's actually been very popular there. There's a Swedish version, a Norwegian version, and a Danish version as well, as a French and Spanish. And there's one other one that I'm blanking about. So we have those. And then we have these two uniquely, not uniquely, but very strongly associated with French language television, called short coms. And I'm going to try to show you an example of one because I'm guessing people have not seen them. We'll see if that works here. And I really, after some analysis, have decided that we really need to split these into two subgenres. So short coms are this really distinct television format that originally comes from Quebec and then got imported into France. And it does exist in other European countries, but France is where it's really blossomed and is the most dominant. And so these are sitcoms. They follow the sitcom form, but they're very short. That's where the name comes from. They're only like 3 to 5 minutes long at most. But unlike sketch comedy, which also is very, very short, they feature repetitive characters and repetitive storylines. And so it really started with Angar and Phi in Quebec, and then there was a British, French remake of it, and I'll show you an example of that in a second if I can. And then the other one, has anyone heard of Breath? I'll show you an example of this if you haven't. Well, so I'm going to show you an example regardless, but I'm guessing you haven't seen it. So these are short coms as well, but they have a very distinctive style. And what's so interesting is when we get to the analysis part of this, you will really see that the two kinds of short coms, the fixed frame short coms and the hyper-edited short coms, actually bookmark all of the features of everything else. Let me see if I can actually, we'll see if the multimodal presentation can have multimodal presentations. Let's see. Yeah, so you can see, so it's playing with the sitcom form that it's very short, but these characters have a personality and you see them over and over again. And he often acts like a little child, and she's kind of this woman who has a lot of feelings about it. It's basically the plot of it. It's basically a sitcom, but really short. And then this is Bref, which it has subtitles, but you're gonna have to read really fast because, well, that's why it's on TV, which is very cool. But they kind of remind me, and probably you as well, it's like something you would see like just on YouTube short, like not on TV, and might actually surprise you that this was on the primetime French television, and it would just appear before the news, basically. And yeah, and each one has kind of a saying, and he always ends with bref and then explains in one phrase what happened there. So those are, I think, have a very similar feeling to them, but are structurally very, very different. And we'll see how that looks here. So basically, this is the part where I'm saying that this is a work in progress. So we have a collection of series from all of these, ranging from the multi-camera sitcoms, which is a big part of our original study. So we have nearly 2,000 episodes of that, all the way down to sketch comedy, which is one that I added this weekend because I thought it would be fun, and it was. To add in there, but we certainly need more, and I actually ordered the complete Monty Python Flying Circus, which is sitting at my desk at home, hopefully. So we only have 15 of those, but actually already we can have some interesting results, I think. So that's our corpus. So what computational techniques can we actually use this with? So I'll go through this quickly because others have talked about it as well. But basically, we are going to do everything using algorithms rather than hand recording shots like Lauren explained. This is a lot of detail that we don't really need, but sometimes slides have a life of their own, and these are the details you would actually need to replicate it. So these are all the how we actually got our digital data and what it's there. So that's really good reference stuff and really boring to talk about, so I'll skip it. So the first thing that we do is we take each video file and we split it up into shots using Transnet V2, this deep learning algorithm that works relatively well. And then we have some custom code to figure out crossfades and fade ins, fade outs, and wipes. We'll talk more about that later if people are interested in the details there. And then for audio annotations, we are really interested not just in the visual part, but also the audio part. This is the only one where we're still really reliant on a commercial model because we have not found an open source alternative that is nearly as good. And this is Pianote's Precision 2 model. If you've ever used Pianote's open source model, it's terrible. And you might think, oh, it's terrible so they can sell their commercial product, which is probably true. But there are no open source ones that work nearly as well. So we continue to use the Precision 2 model. And this gives us diarization and speaker timestamps, and it works very well across multiple languages, which is important because we have French, German, and English data in our corpus. And then on each of the individual frames, we apply a sequence of models. We use SIGLIP to do so that we can do multimodal embeddings. DynoV2 to compare the structure between shots so we can find when one shot goes back to that same shot later, like in a shot reverse shot sequence. And then grounding Dyno to detect faces, heads, ears, eyes, nose, and people. Grounding Dyno is cool because you can find bounding boxes for things without having to train a model. It's all zero-shot learning. And so basically we do this. We originally had this complex thing of trying to figure out which frames were the best to use and developed all these really complicated transitive dependencies that like you had to run the shot detector and know that it worked well before you knew exactly which frames to look at. And every time, like Lauren will tell you, I was like screaming at the computer that I had messed something up, and then I had applied SIGLIP2 to all the wrong frames. And so I kind of gave up on that and then just decided to do it every 24 frames, which is about a minute, about a second. And that works really well. And it makes me calmer. So I really like doing that. And it's actually really nice and has some downstream benefits as well, just doing it every second. Just to give you a sense of what the size of the data is, that's something I get asked a lot. So this is Abu Sufla, which you kind of watched when Lauren tried to show you, but I know it didn't quite work, but great film if you haven't seen it. We have it stored in HD 1080p. And the file size, we have it down to about 4.5 gigabytes. The audio file, if you extract, it's about 22 megabytes. And all of the other features that we have range from a couple of megabytes to, I don't know, 100 megabytes-ish, with the exception of the thumbnail JPEGs, which are about twice the size of that. So all very, very groppable, very storable relative to the size of the raw video. Okay, so here are some initial results. So let's just take one metric. This is one of the metrics that is kind of the bread and maybe ASL is the butter of cinemetrics. So this is the bread of cinemetrics, MSL. So it's just, we take all the shots and we take the average length of them in seconds. How long are they? So on the right, I have for each of the series in our corpus, computed the median shot. Median shot, sorry. Yes, I always get confused because it's M, could be mean or median. I'm sorry, MSL is median shot. So the middle value, which is a little bit more stable. So I'm looking at the median shot length here. And so this goes from Moitié, which is another show like Bref Bref's at the bottom. Moitié is another one that I'm guaranteed, and that was the one that we saw here second. And the table is very long, so I just showed you the most extreme ones. So these short comms that have only one shot, if you remember, it was just one camera, it never moved, and it just recorded this domestic scene. And those, the top 4 slowest shows in my corpus are these French short comms. And then the top 2 fastest are these other French short comms that actually have cuts in them. So this is why I was saying they really bookend the data set. So if we make a table like this, and you write a paper and you're a statistician, so you write a paper like a statistician, the thing that everyone will ask you is like, well, why don't you do some p-values? Because you should do p-values because you're a statistician. And I don't think that's a good idea, which we'll come back to in a second. Because how do we really know that these are meaningful? I mean, there's a pattern to them. To me, I like patterns. It doesn't seem random. But how do we know that it's really meaningful? How do we know that 5.8 is meaningfully different than 4? How do we know that 1.7 is meaningfully different from 2? Or is it? Maybe it isn't. And it's very hard to figure out how to do that. And I wanted to spend a little bit of time talking about that challenge. So before I get there, it says QDA plot. That's not what this is. This is just a plot of the median shot length. So I have each of the series on the left, on the y-axis here, sorted from the fastest to the slowest to the fastest. And each of the dots is an individual episode. So you can see that this is not, I hope that you see the same thing that I do, which is that this does not perfectly bifurcate the data. There is quite a bit of spread in each of the individual episodes, but there is also a signal. If we take shows down at the bottom, nearly every single episode is dominated by nearly every episode at the top, right? So it doesn't matter which episode of Breath that you open, it's always going to be a lot faster than a random episode of Arnold. That's what I'm saying. So we have this thing and I can plot it. And how do I go from this, especially if I have the challenge of multiple metrics and multiple ways that I want to look at it? So that is the statistical consideration. So I warned you about this. And so what we're going to do is we're going to take just 2 examples. I originally wrote A and B, and then I realized that we should have a real example. So I made A all in the family and B breath. So I grabbed those 2 from the data set. So let's say we have here, and I actually switched now to ASL for average shot length. So this is the butter part of the cinemetrics. If I actually do observe these and I write them down in like my statsy brain, these are the sample means, these are the sample standard deviations, and these are the sample sizes. How can we characterize the separation between these series, right? This is kind of the question, the core ideas. I have this data and I observed that, okay, yeah, one is a lot faster than the other on average, but is it meaningful? What does it mean? Does it actually characterize something? Is it just random? Wait, is it just happens to be this way and another metric would be this way? What can we do with that? And so my proposal is that we use predictive classification. not because we care about classifying. I can pretty quickly tell if something is from breath or not. I can detect who the character is. I can look at the aspect. If I really cared about classification, it would be super, super easy. But rather what I'm going to use is I'm going to use it as a proxy for measuring difference. And I'll show you why that works really. And I'm going to show you by explaining some of the alternatives and why I don't think they work as well. So the first one is null hypothesis significant testing. So I basically every time, you get the reviewer two, my reviewer two always says you should do a hypothesis test and a p-value and give me some p-values because I write like a statistician and I think at the end you sort of expect there's a p-value. And so yeah, so this is one option is we could have a null hypothesis testing framework. We could say our hypothesis is that these two series are exactly the same. And do we have evidence that they are different? That's essentially null hypothesis significant testing. We could do a t-test here for two samples. We could extend that to times t squared, MANOVA, ANOVA, et cetera, if we have more than one series or more than one metric. I do know these terms, I just don't use them very often. Okay, so the other thing that we could do, which I think actually works a little bit better, is do effect size calculations. So this is a way of saying, look, the t-test is really designed to say, is there a difference, period, end of story. But actually, we care as much or more, or maybe even exclusively, in measuring not is there a difference, but is there a meaningful difference, and trying to measure that in some ways. And the problem with p-values is that if we have enough data, you look at, that's why I don't usually put equations just to put equations, but this one is important here because what happens is regardless of how different those two means are, if I have enough data and the limit as n goes to infinity, my t statistic will go to infinity as long as there is some signal. And that's a good feature. It's called consistency. It's a consistent metric, which is really nice, but it's not great here because I'm basically mixing together my effect size and my sample size. That's not great. So what we really want is something that just measures how different are these two things. One of the really nice metrics is Cohen's d. You just take the difference of the two means and you subtract by the pooled standard deviation. And this just gives you a measurement of, in practical sense, how different are these things. It's very common in medicine. It works really well because everybody who works in biometrics or statistical medicine knows, like, for certain diseases and certain kinds of drugs, what's a good d and what's a bad. And you can extend this to more cases of more data and more metrics. No problem. So I'm less critical of that one. And then the third and final alternative would be a Bayesian method. So we can actually say, look, our uncertainty is not really about the data. I have every single episode of breath. Like, there aren't any others that I don't have. But really, my question is not the data itself, but the mechanism which generated the data. So is breath really fast because it's meaningfully fast, or does it just happen to be fast? And so this gets a bit philosophical, and I don't want to go down that whole road right now. But we could basically, we could put this Bayesian hat on and think about, well, moving the source of uncertainty from the data to the data generating process, which I do think has a lot more utility for us. And then if we actually do one step further, we could do a fully Bayesian model where we think that each episode's metrics come from some normal distribution, and that normal distribution has a mean, which itself has another distribution, which has some parameters, which I can then set and then change. That's Bayesian modeling. Great idea in principle, really hard to actually apply. And so my proposed approach is that instead of doing that, we use this technique, a classification technique, and I'm actually going to use quadratic discriminant analysis. Sounds really fancy. What it basically means, I'm realizing that my description is not going to make it sound a lot less fancy. But okay, what it means is that you fit a Gaussian distribution. You fit like a nice bell curve distribution around all of the metrics for a particular series or group of series, depending on what we're doing. And for independently, so for every episode, for every series, if we want to classify series, or every subgenre, if we want to classify subgenres. And then what we do is we look at them all independently, and we use them to calculate the relative probability of a random episode coming from each of those distributions. And then we can see, oh, this random episode of breath, does it come from the distribution that I built around breath, or is it more likely to come from this other distribution of another sitcom, maybe? And then so if I look at this, it gives me a sense of the separation in a high dimensional space in a meaningful way about the metrics that I have chosen. And it has a real nice benefit that I can easily scale up to multiple episodes, or multiple categories. And I can easily scale up to multiple metrics. And I can easily interpret the output because they're just probabilities. And I can rest on that this is sort of an approximation of a Bayesian method, but it doesn't have all of the machinery and the complexity of the Bayesian method. So it can actually be interpreted as an approximation of a Bayesian technique. And so I've kind of already given my response to all of these things. The null hypothesis, significant testing, why don't I like that? There's really no population, there's no unknown about my data. I have the data, I have everything. It's not like I've given a drug to 10 patients and there are thousands of other patients I haven't tested. I have every single episode of this show. So it's really asking the wrong question. Effect size calculations aren't wrong, but they just have trouble scaling in multiple dimensions and multiple areas, multiple dimensions and multiple groups. And the benefit of them is that they go hand in hand with the hypothesis testing. If you aren't doing hypothesis testing, Cohen's d is just another choice of many different, and there's no particular reason to prefer it over anything else. And the Bayesian methods, like I said, it's really correct. It's just and philosophically correct, and it's the way I think about things all the time. And QDA is in fact Bayesian, but we're just not using the full machinery because it's too complicated. It's too sensitive. You can just change a little parameter and get completely different results, and my technique does not do that. Okay, so now some better results, I think. So what we did is we took this corpus of television comedies and the algorithms that I showed you and computed for each episode 9 different metrics. So the median shot length, the average shot length, the proportion of time that someone is in a long shot, and long in terms of distance, in a close-up, the proportion of time that someone's in a one shot, so there's only one person in the frame, the proportion of time that there's a bright light, we just used a threshold there, it probably needs to be modified a bit, but for right now, we're just using a threshold. The proportion of shots that have a high movement, so that's where we use that dyno algorithm, the first frame and the last frame of the shot, and see has it changed a lot. The percentage of time with speech, so how much are people speaking, and then the median turn duration, so how long does someone keep talking until someone else keeps talking. And then we get these results over here, which sound kind of, they sort of seem thrown over there, but this in a way is the big thing that we have so far. So essentially we can look at different metrics and classifying 2 different things. So we can either try to predict the subgenre that something is in. So this is a short com, this is a single camera sitcom episode, or that's the top part of the chart, or I can say this is from Bref, this is from Coco, this is from All in the Family. And so the second one is much harder because I have to get the series right, not just the whole genre. And then I can use different metrics. So the first 2 are the ones, the cinemetric bread and butter. And then I can look at all of the oral ones, which are, did I put them next to another? It's number 7. No, sorry. Number 8. Oh yes, number 8, number 9. So just the ones that have the speech side of it. And then I can look at all the visual ones, which is 1 through 7. And then I can look at all of them. And so obviously if I throw more metrics in, it will get better. The question is, does it get a lot better? And then on the table, I have the balanced error rate. So it does account for the fact that some classes have fewer things in it. That's actually built into it. And then the top 2 error rate, which I'll talk about in a second. And so this is the real big takeaway, is that even the simple, is this a short com, is this or a multi-camera setup, even that one, the cinemetrics one, the one that everyone's been using, is terrible, actually. The error rate is 0.6. So that means that 60% of the time you put it in the wrong bucket. And even in this big bucket, like all of the multi-camera sitcoms, etc. If we increase that to look at the oral set, it gets a little bit better. Obviously, I think because we only have 2 of the features and there's only so much in the audio, it's not going to be super powerful. It's interesting that it's actually already better than the one that the cinemetrics people have been using for a long time. If we add any other visual features, it jumps way down to about 0.28. And then if we put them all in, and this is why multimodal is important, we get about 20% error rate. So 1 time in 5, I can't figure out which set is this something from? Is this particular episode from? And then the series tells a similar story. It's a harder task. It's really interesting that with all the features, we can actually do for series pretty well. So 1/4 of the time I know, 3/4 of the time I tend to know exactly which series this is. So this is pretty characteristic of the structure of an individual series. And then the second column here is very interesting to me. I mean, you will see this number here in particular is quite low, about 4%. So what this is that we basically allow the model to predict two different options, and it's right as long as one of those two is right. And the reason that's fair is because, and what I think this is actually showing us, that it's very, very low. We make very few errors if I allow it to make two guesses, is that I think this gives evidence that these genre formations are not binary things, but more of a continuum. Maybe within a series, maybe across a series. But the idea is that, like, well, this kind of looks like a mockumentary, but it could also be a single camera. And mockumentaries are single camera sitcoms. They're just a particular subtype. It makes sense that I have trouble telling them apart. It's actually pretty amazing that I can do so well in the first place. And then when I allow it to make two guesses, it's really, really good. So it's noticing that when it makes an error, it's not completely confused. It's just hitting the boundary between two genre types, which are not, I think, super well defined. I think it's more of a continuum. And then quickly, I'll just show you, so we can also look at the confusion matrix. This is another nice thing that we get from using the predictive modeling approach. So we can see exactly which shows and which subgenres get confused with one another. And we do see, for example, there are quite a lot of mockumentaries that look like single camera sitcoms, and that makes sense. Actually, our original study, we put them together. Yeah. And in some way, mockumentary is a subset rather than an independent type of a single camera setup. So there's that. And then I'm going to go through this quickly. I think there's a lot here, and this is where I think we still have some work to do, is because now that we know that these are all separated, that's kind of the conclusion I feel pretty confident about. That means that if we look at the centroids, if we look at what is a typical short com, what's a typical news comedy, what's a typical sketch comedy, that those are meaningful because, well, if I have all these numbers, I can classify almost everything in the right category bucket. What does this actually tell me? Well, maybe it's, for me, it's sort of I've made the first pass of this, which are things I already knew having studied this a little bit, like short coms and panel shows are very fast. News parodies and short coms, the classical short coms are very slow. News has a lot of speech. Which one has a little? The early single shots have very little because they had a lot of kind of gap time to fill in usually they had a laugh track, but it was canned laughter. And so they had these big pauses to push them in. So I think there's more here, more to be studied. And I just want to sort of say, this is where we're going and trying to actually connect this with scholarship on the genres and how they actually form comedic elements. But we've done a lot of work to say that these are meaningful. What do they mean? Well, that's kind of the next question. They're meaningful, and we don't really know. And this is just a cool plot because you can actually plot the QDA analysis, and it's messy on my computer and even messier there, so I'll just, okay. So I will just finish with some conclusions. I'm trying to go back to the questions I asked at the start. So in summary, predictive models, yay, I love predictive models. In particular, Bayesian motivated techniques, and in particular QDA. You could also do LDA. The difference is that the way that you make the shapes of those Gaussians with QDA, each subgenre has its own shape. With LDA, they all have the same shape. So what that means is that you can't say, oh, in news, we have a lot of variance in MSL, but very little variance in speech. And in a short com, it's the other way around. Everything has to have the same correlation structure. When we use LDA, it also works pretty well, but not quite as well. But all of those serve as an excellent way of measuring how well a given set of metrics can distinguish groupings. And those groupings could be different things. Right now, we're looking at two categories. We could think about collapsing certain subgenres or splitting them apart and doing them in different ways. The second one, which is probably the most shocking is maybe the wrong term, but interesting in terms of the current scholarship, is that there's classical cinemetrics metrics are really far less able to distinguish subgenres and series than other visual features. And that is actually surprising because of the dominance of ASL and MSL in the literature in quantitative analysis of film, that actually they're not quite as good as some of these other features, particularly if we mix oral features in with visual features. So oral features help us separate, which means it helps distinguish these different things. And we're also working on applying this to film to see, is it maybe a feature of television, or is it just that MSL and ASL were the easiest things to calculate, and that's why they used it, but they're actually not the most predictive. And we are able to separate individual episodes from individual episodes from a series or individual episodes from a subgenre fairly well. And then if we allow it to actually pick the one of best two, which would account for the fact that some genres actually feed one into the other, that a short com is kind of like a multi-camera sitcom. If we allow for that, then our prediction rate was very, very low and we get less than 5% classification rate. And again, that's on every individual episode, which like within the example of breath can be very small, it can be like 2 minutes. And we're still able to know that this looks like breath. Not, I mean, obviously if we did face detection or if we use like features or, we use the text, of course, like there are character names that they use, but these are just high level stylistic features that it's very distinguished from the rest of the corpus, which is very cool. I will be honest, these numbers are better than I thought they would be. And I'm very excited about how much of a style we've been able to find from less than 10 features. So thank you so much.
Well, you guys took my suggestion to move quickly through the material to heart. And so we actually have 10 minutes for questions. There was a question that came in on the Q&A, and I think this was for you, Lauren. And this is from Brian O'Connor, who's online, and he's asking, why are you still using cuts and shots as units? At Berkeley in the 1980s, we began looking at frame-to-frame changes, and it says now pixel to pixel across frames. So I think that was just a question about why these features and not something much more defined range.
I mean,
I suspect you can hear you because the microphone's over here.
I mean, part of it is that there's always a flip side, which is one of the things that we're always trying to balance is when makers or filmmakers say we care about the cut or the shot, that's a unit of analysis that they are building their movies with, and there's historical emphasis on that. And we want to be careful that we're using the ways of seeing that are framing the actual formation of the form. So if people are thinking of their work as cut and shots, then that's one way to go and look at it. So it's not like a person in 1930 is thinking pixel to pixel. In fact, they're not even thinking about pixels, right? They're thinking about literal celluloid that has a series of frames per second, and they're thinking about frames like speed per second. Do I do it in 16 millimeter? Do I do it in 72? Do I do it? There's all these negotiations of film speed at the frame. So I think that that's where sometimes there can be a disconnect between. That's why the question of what are our unit of analysis, like, and whose frame are you coming at it from, and what are the ways of seeing that are built in.
And I think too that like I've actually tried to move away. I mean, I haven't because I was connecting to other research, but I like the idea of thinking about cuts rather than shots.
Yeah.
Because cut really is something at the frame level, and it's just that is an interesting event that happens at the frame level that we want to know about.
Okay,
and
so Brian says thanks, and he says he asked that as a former filmmaker.
Oh, okay.
So I think one of the other questions might be transitions between cuts, and if you've been looking at sort of transition energy.
Yeah. I mean, transition is interesting because of there's all kinds of different kinds of transition. So like, we have been thinking through that. And, one thing is about one thing we've had challenges with is like, for example, when you have like film magic, TV magic, where they use basically a fade or a white, someone does magic and it's actually not a transition in this the scene, but it actually acts like a transition. It acts like it's a cut. So you could think of like Samantha or Jamie, and there's a burst on the screen to signal. So there's some things like that that make it challenging. And then also with transition, you can think of like
there are just different kinds. And actually,
Yeah.
one of the things that I didn't say in here is that there was one series that I got rid of because we were having so much trouble with it, and I need to go back to the data, which is the Big Bang Theory. Because when first of all, it's terrible, but also when it has a cut break, they often do this thing where they have like floating electrons, and it has like a bunch of really fast cuts, and then they go back to the other one, and it's a question of like, are those real cuts? Is that a transition? Should I just treat it as a button? So it's a good example of like, I don't know what to do with it, and these transitions are hard. So we just got rid of it because I don't quite know what to do with those breaks. So
Big thing is not bad. Come on.
it's pretty bad.
Kid loves enjoying it.
So I'm just gonna let you guys.
Yeah, sure.
Yeah, so I have a question that follows up from that, which is, have you thought about kind of like the sequence of the shots? So, first of all, this is cool, like the top two error, I think that is like really kind of fascinating. And, but you know, I was thinking when you showed the examples of breath, that they have like a rhythm to them. So it's like, you know, kind of like shot, and then like the humor is this extended thing.
Yep.
So have you thought of representing these as some kind of like sequence that they use like a kind of like a classifier that looks at the kind of genre, like the way that you look from like say bag of words, bag of shots, I suppose, in sequence?
Yes.
Yeah.
Yeah, we've thought about it. It was one of the other annotators we put in, and we just haven't gotten to that yet. But like one of the interesting things would be how often do you go back to a shot that we've seen before? And
Well, or even if it's not the one before, it's just like a rhythm. Like,
oh, sorry, like before at some point. But yeah, I guess you could like if it's very consistent or not, the pacing.
yeah, even if it's not kind of like, you know, yeah, it's like, you know, shot, like, you know, it's like you could represent it as a sequence of like duration
Yes.
without knowing exactly what the content is. It's just,
Oh, yeah.
is there like a signature on the kind of, you know, the kind of, yeah, durational,
I think it's a good approach. We've spent less time on that because the cinemetrics people have done that a bit because they had a lot of the shot data. They wanted to use fancy stats, but they didn't have an easy way to generate more annotations. And so they've done a lot of that before. And Lauren, I think, showed one of the films over time. Was that the pacing of, I don't remember which one it was you showed.
From.
You showed the shot length over time, like how it goes throughout the shot of
Oh, yeah.
a film.
From,
I don't know, that was my question.
oh. I'm gonna show.
I don't know, maybe we'll pretend that it was.
so
So that's one of them, but I think there's a lot there. But I actually think that much like the shot length, that you actually need something else. So you need to know, am I going back and forth between like a dialogue shot and over the shoulder, like back and forth that way? Or am I going from a master shot to a close-up to a master shot to a close-up? And I think the reason that the cinemetrics people never found a lot from exactly what you're describing, which makes a lot of sense, this like treating it as a time series, is that you need another dimension to make sense of it. There's just too many other things that can happen. But, yeah.
Thank you very much. Okay. I thought it was super interesting. I was thinking that, so I recently also worked in genre, but in literature. And in our case, we saw that like trying to define, let's say, to assign one genre to each book was very simple for some books and very difficult for others. So the same label didn't always have the same weight, even by the humans who were giving it, right? And so we were trying to kind of work around that by doing a little bit like you did, so imagining these clusters. But basically we trained a classifier only on things that were really clearly, let's say, the center of the genre. So typical genre X. And then try to classify the things that were a bit in between. So what remained. And in that case, we found that, as you were also saying, there were these things that were, let's say, classified as a genre, but they were not so, the model was not so sure, so confident that there an element of error. And many of these things were actually things that also the humans or the critics found that were a little bit in between the situations and the right. Nodding, so I imagine that you're also thought about that. And we found that was also very informative, much more informative than basically it was actually a better model than just trying to break the space.
Oh, interesting. Okay. Yeah, so that's a really good point. I mean, it's one of the reasons I like this QDA model. Because basically what you're trying to do is define the distribution of a specific group, but you're not actually really doing classification. It is modeling that group as a thing. And I just showed this plot that I said was indecipherable. You reminded me that it's somewhat decipherable. So this big plot, this big piece here is television news. And you can see it's kind of not round, but long, because there are, I think it's actually shot length is quite variable, but it always has a lot of speech. And so that is kind of like you were saying, like, it's basically learning that some directions really define it. It actually goes opposite. When it stretches out, that means it doesn't define it because you don't really know what it is. And when it's very narrow, it defines it very well. So it's actually, that's why I like QDA, is because it's actually doing exactly what you're describing. Yeah.
And you can look at the things in between.
Exactly.
They are actually considered hybrids. Right?
Exactly. Yeah, it's a good point. Yeah, so maybe that's where we should go next, is actually looking at the things that end up in between. Where are where the transitions. Yeah, that's a good point. Yeah,
Thanks for the talk.
Yeah, of course.
Fascinating. I also really enjoyed this next part. So.
okay, excellent, thank you.
I'm curious because, I'm really curious about this idea of using like predictive classification or like predictive models. I think like when I think of a predictive model, one thing that I think makes it really compelling is that you can make like a very expressive model. With like, and you can do like feature learning, right? With like neural networks, and you can work in these like high dimensional spaces. But then I guess I'm curious, like, do you think the things that you're saying about like the benefits of using this like predictive model approach, like, do you think like that persists if we use these like high dimensional feature spaces that are less interpretable, or do you think like you need like a better understanding of the generative process for this act work, and you can't just like train a discriminative model?
Oh, that's a great question. So what I said sort of tongue in cheek, but actually meant was that this is that I feel like we've shown that there's a meaningful difference, but I haven't figured out what the meaning is yet because we haven't really had time to look at this yet and do some of these things like where do they overlap and all of that. And I think that transition is where we run into a problem if we use a fancier model.
Yeah.
So we can still say, oh, there's a difference. I can classify as long as I properly use a training test. These are actually all the QDA is so fast. I'm just using leave one out cross validation. So every episode doesn't have it in the data set. I just run thousands of models. So it's really nuts. I forgot how fast these are relative to now in the LLM space. And I think that's the problem because once you have a really fancy model, all I can really say is there's a difference. I'd have to go back to some of the other methods to say what that difference is. I don't know if you agree with that, but that would be my like knee-jerk reaction. Okay. Yeah, that would be my sense. And that's why I'm trying not to use that. So I have the same model that I can then, what's nice, QDA develop centroids and you can just look at them. The centroids there, this is an LDA space, are those. That's the same thing. And so I like that the model is using the thing that I'm then interpreting. But sometimes you can't do that, and then I think it still has some of those benefits, but not all of them. Yeah.
I think for this, it's really classification analysis is really fun, and I think shows how important multimodal features can be. For this kind of analysis, I mean, could you do just basic feature importance tests just by leaving out a feature and seeing how
so that's what this is, where we only have the MSL ASL, and then we only have the oral, and we only have the visual, and then we have all of that.
Okay, yeah. So I was thinking about like for a specific.
Oh, like drop one out.
For everything or for a specific one. I guess more specifically, I would be curious to know what makes the difference between the modern single camera versus starts.
Yeah, you're right. You could start going through and dropping them one by one. Or you could just compare the centroids, which is a little
No, that's good. That's the part that I am talking about.
Okay, sure, the
details of how that works. Because so for the evaluation, you're basically you're sampling, you said like artificial episodes, you're creating artificial episodes.
Oh no, so for every single episode, I pull it out of the data set, I fit a model on everything else, put it back in and test it, and then I repeat because it's like super fast.
Right.
Yeah.
Okay.
Yeah.
Is there anything that's related to the published year of those TV shows? Meaning, I guess because of the popularity of those short videos, I guess the mean short class and average short class may, as the year goes, it may decrease. Is this something related to why the mean short class and average short class not as acceptable as we expected?
Oh, interesting. My instinct is that it's not the reason that we can't do the classification as well with them, because of the way the model is trained. Even if Friends was season 1, Friends, season 2, season 3, season 4, it would still work. It would just be that it's now because the mixture of Gaussian is Gaussian. So even if you wanted to do each season separately, we just have more power doing it the way we're doing now. So I don't think that's the reason we have that, but there is a temporal difference. We found it less within a series, but more across series. So over time, they have, even within the multi-camera genre, they have gotten somewhat faster. But it's the cinemetrics people make it sound like it's this massive slope, and it is not nearly, it's much more subtle than the cinemetrics people kind of describe in some of their work. At least for our data, maybe theirs is very.
Time for one or two more questions.
Yeah, please.
I'm just kind of curious, especially do you find anything interesting? I'm curious to see what they kind of thought within, but I would guess that worse or better as it kind of directly agree something system. So I was just curious about
With the news parodies or the genre parodies?
I guess the genre.
The genre parodies?
Yeah.
Yeah, so that is actually kind of a to-do for me, because right now they're very well separated from everything else. I don't think I have the F1s with, they're actually one of the easiest to classify from everything else. The Good Place, Murders in the Building, the other one that we have, Psych. And so they're very easy to tell apart, but what I think would be more interesting, I don't know if that's what you were thinking, but they're very different. But I think the problem is that they're very different because, in kind of an artificial way, because they do still have features of the genre that they're parodying. And so what I really need to do, I actually have the data but haven't run the algorithms yet, is compare it to Law and Order, like Psych to Law and Order, or Psych to, Murder, She Wrote, other police procedurals, and see how it compares to that. Because I'm with you. I think what would be really cool, but it never works out this well, is if it like sits right in between the two. If it's like a blend of a single camera sitcom and a procedural. But I don't have the second piece. I'm sorry, what were you gonna say?
I was gonna say I agree with also like way extract what makes it funny, or it kind of gets rid of like the laugh track issue.
Oh, yeah.
I'm not feel like mine is that specific control feature.
Exactly. Yeah, that's a great point. Yeah.
One last question.
Sure.
I just have I'm curious if you have any features that you wanted to include but didn't include there, in 9 features up there. And sort of related to that, I think for features like shot, it is at the same time a technical decision that the filmmakers make. There's the artistry associated with shot, what they call dimensions associated with shot. And there's the things that you can achieve with the shot, model, slick, click.
Oh yeah,
And all the models can do.
yeah.
You see any tension or how they can mutually inform your design choices and how they determine the arguments you can make with the measurements they would take.
Yeah, well, I'll answer the first part just in time, and then we can talk about the second part later. But in terms of other metrics, it's basically kind of what Miguel was alluding to. So the idea that right now we're sort of looking at individual shots or individual moments, and I would really like to look at like how often do you go back and forth in a dialogue scene versus how often do you go back to an establishing shot and then into. And I think that would be very characteristic of different shows, and I think that it would be really great, but it just takes a little more work to get to. And I have the code, but I haven't validated it yet, so I didn't put it in. So yeah.
There's one last question online, and then we're going to wrap it up. How robust are the results to temporal and generational shifts? And could reprocessing the data in the future lead to significantly different conclusions? So one is a sort of future, can you imagine you would get different conclusions? And the other part, the earlier part of this question might actually be more easily addressed. Temporal and generational shifts, how robust are they?
In terms of the temporal shifts, they're robust in this case, although one of the things we're cheating, I don't know if that's the right term, but there has been a temporal shift in the genre. So we don't really have a lot of multi-camera sitcoms anymore. We have mostly single camera sitcoms. We saw the shortcoms changed a lot, and I just made a different category for them, although they're both shortcoms. And so I think they're not super robust because genre is constantly changing and reinventing itself, and eventually kind of splits from what existed before. That would be sort of
Great. Well, thank you very much. And thank you all for attending.